Alright, so in this video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of 8 minus 121 is equal to 0. Now, what most people would think to do to solve this equation is add 121 on both sides. So then I would get x to the power of 8 equals 121. And then, since x is to the power of 8, take the 8th root on both sides to get an answer of the 8th root of 121. And this method is actually wrong because there are actually many more solutions than just 2 to this equation. There's many more. So we want to find all of these solutions to this equation. So how are we going to do that? Well, our first step is to rewrite x to the power of 8 as x to the power of 4 times 2. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 times 2 is equal to x to the power of 4 to the power of 2. Now I have this minus 121, which we can rewrite as 11 to the power of 2. And the reason we're going to do that is so now we can use an important algebraic property that states that if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x to the power of 4 and b is 11. So I get x to the power of 4 plus 11 times x to the power of 4 minus 11, which is equal to 0. Now, from here, I get two equations. I get x to the power of 4 plus 11 is equal to 0, and x to the power of 4 minus 11 is equal to 0. And we are still not done yet, because to solve this equation, people are going to think, oh, add 11 on both sides and take the 4th root. But we're going to do the same thing we did with our original equation. I'm going to rewrite x to the power of 4 as x to the power of 2 times 2. And now I can rewrite that as x to the power of 2 to the power of 2. And 11, I'm going to rewrite as the square root of 11 squared. So now I can use this property again. So I get x squared plus the square root of 11 times x squared minus the square root of 11 is equal to 0. And again, I get two equations. I get x squared plus the square root of 11 is equal to 0, and x squared minus the square root of 11 is equal to 0. Now, what I can do is, for x squared minus the square root of 11 equals 0, I'm going to add the square root of 11 on both sides. So then these two cancel out, and I get x squared is equal to square root of 11. And now if I take the square root on both sides, square root of x squared is x, and the square root of 11 is the 4th root of 11. This is positive or negative. Now for x squared plus the square root of 11 is equal to 0, I'm going to subtract the square root of 11 on both sides. So I get x squared is equal to negative square root of 11. So now I get the square root of x squared is equal to the square root of negative square root of 11. So the square root of x squared is x. And the square root of the negative square root of 11, I can write this as negative square root of 11. So now this is the same. So now if I take the square root on both sides, I get the square root of x squared is equal to negative square root of 11, or sorry, the square root of negative square root of 11, which I can rewrite as x is equal to the square root of negative 11 to the power of 1/2, which is equal to negative 11 to the power of 1/2 to the power of 1/2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 1/2 times 1/2 is 1/4. So I get x is equal to negative 11 to the power of 1/4. Now going back here, I have x to the power 4 plus 11 equals 0. So I can subtract 11 on both sides, and I get x to the power 4 equals negative 11. Now I can take the fourth root on both sides. So I get x is equal to the fourth root of negative 11. And this is positive or negative. Alright, so in this problem, I have 1 over a to the power of x plus a to the power of x plus a to the power of x plus a to the power of x is equal to 64. So I obviously want to find the value of x here. So for my solution, I'm going to first start by rewriting my equation over here. So I have 1 over a to the power of x plus a to the power of x plus a to the power of x plus a to the power of x is equal to 64. Now from here, notice how I have 4 of the same terms for my denominator, meaning I can just factor out that one term. So I get 1 over a to the power of x times, well, a to the power of x divided by a to the power of x is 1, so I get 1 plus 1 plus 1 plus 1, which is equal to 64. And now 1 plus 1 plus 1 plus 1 is 4, so I get 1 over a to the power of x times 4 is equal to 64. Now from here, I'm going to rewrite all these terms in the power of 2. So 4 here is equal to 2 squared. 8 is the same thing as 2 to the power of 3. So I have 2 to the power of 3 to the power of x. And finally, 64 is the same thing as 2 to the power of 6. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x over here, that's going to equal 2 to the power of 3 times x, which is simply 2 to the power of 3x. And I have this times 2 squared is equal to 2 to the power of 6. Now I can multiply both sides by 2 to the power of 3x times 2 squared. So and these two cancel out, or sorry, these 4 terms cancel out, and I'm left with 2 to the power of 6 times 2 to the power of 3x times 2 squared is equal to 1. And because all these powers have the same base, well, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So let's first start off with 2 to the power of 6 times 2 to the power of 3x. That's going to equal 2 to the power of 6 plus 3x, and now I have this times 2 squared, which is equal to 2 to the power of 6 plus 3x plus 2 is equal to 1. Now 6 plus 2 is 8, so I get 2 to the power of 8 plus 3x is equal to 1, and I can write this as 2 to the power of 3x plus 8 is equal to 1. And now 2 to the power of what number is equal to 1? 2 to the power of 0, right? So I can write this as 2 to the power of 3x plus 8 is equal to 2 to the power of 0. And now, solving this is pretty simple. If I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 3x plus 8 is equal to 0. And now we have a simple equation. All I have to do is subtract 8 on both sides, so I get 3x is equal to negative 8. And now if I divide both sides by 3, I get x is equal to negative 8 over 3. So now, to check, my original equation was 1 over a to the power of x plus a to the power of x plus a to the power of x plus a to the power of x is equal to 64. Now, we know that x is equal to negative 8 over 3. So, I'm going to plug in negative 8 over 3 in place of all my x's here. So, what is 8 to the power of negative 8 over 3? Well, 8 to the power of negative 8 over 3 is the same thing as 1 over 8 to the power of 8 over 3. And 8 to the power of 8 over 3 is the same thing as the cube root of 8 to the power of 8. So we have, well, 8 to the power of 8, 8 to the power of 8 over 3, I can rewrite 8 as 2 to the power of 3. So now I have 2 to the power of 3 to the power of 8 over 3, and these two 3's cancel out, so I get 1 over 2 to the power of 8, which is equal to 1 over 256. So now I get 1 over 256 times 4, which is equal to 1 over 4 over 256. And this is equal to 1 over 64, which is simply equal to 64. Meaning 64 is equal to 64, and our solution is right.